Assalamu alaikum everyone. Welcome once again to the course Digital Signal Processing. Hope you all have gone through the lectures of first week and sufficient interest has been developed regarding the course. Now proceeding further, we have to learn a lot this week too. So let's start with the lecture. Before proceeding to the contents for this week, let's recall the major points we have discussed till yet. Firstly, we have discussed the introduction to digital signal processing, in which we have discussed the basic block diagrams of analog signal processing and digital signal processing and compared both the block diagrams. Afterwards, we have discussed some basic definitions of signals and system and the mathematical expression of certain types of signals. Also, we have discussed the major application areas of digital signal processing as well as the major advantages of using DSP. So these are the points we have discussed till third lecture. This week we will going to cover the first point or the first topic is signals and its types. In this topic we will discuss what are the major classifications of any signal. By mean of classification, I mean to say that how we can categorize a signal. Obviously, we can categorize or classify any signal on the basis of certain parameter. Like in previous lecture, we have discussed there is a difference between continuous time signal and discrete time signal. So basically this differentiation is basically on the basis of certain parameter which is time axis. So the continuous time signal and discrete time signal is one of the classification of signal. So like this we will discuss what are different parameters on which we can classify any signal. Afterwards, we will discuss the manipulation techniques of discrete time signals, which are shifting of any signal, how we can scale any discrete time signal, and how we can reverse or fold any discrete time signal. But before discussing all these manipulation techniques for discrete time signal, we will first see these techniques on continuous time signal. So you will be familiar with the techniques and then you can easily apply these techniques to discrete time signals. After that, we will cover some points regarding the systems, that is fundamental properties of discrete time systems. Classification of signals. Signals can be broadly classified into various categories on the basis of certain parameter. As discussed in the previous slide, certain parameter is considered and the signal is categorized. So the first classification is continuous time signal and discrete time signal. We have discussed this classification in the previous lecture. So by looking at signal, we can easily comment that this signal is a continuous time signal or either this signal is a discrete time signal. Another classification is analog signal and digital signals. We have also covered this classification in the previous lecture. Third classification of any signal is its periodicity. Whether the signal is periodic signal or it is aperiodic. Fourth classification is causal or non-causal and anti-causal signal. We will discuss what this classification is in the later slides. Another classification is energy and power signals. Another classification is deterministic signal and probabilistic signals. So let's start our discussion regarding the classification of signals. As you all know that first two classifications has already been discussed in the previous lectures, which is continuous time signal and discrete time signal, and another classification is analog signal and digital signal. So we are proceeding towards the third classification, which is periodic signal and aperiodic signal. How we can claim the periodicity of any signal, or by looking at any signal, how we can claim or comment that this signal is periodic or aperiodic, we are going to learn in this slide. So the major criteria or expression which will help us in claiming the periodicity of any signal is shown here. It is x of t is equal to x of t plus t naught for all values of time. And what is t naught here? T naught is the fundamental period or time period of that signal x of t. So if a signal satisfies this mathematical expression, then this signal is a periodic signal, and if it doesn't satisfy this expression, then the signal is aperiodic. So by deeply looking at this mathematical expression, or by analyzing this mathematical expression, which is very simple, x of t is equal to x of t plus t naught, and t naught is simply a time period. But by analyzing this expression, a periodic signal remains unchanged when shifted by one time period. What I am trying to say, that look at this signal. This signal has a time period equals to t naught. So if I just copy this t naught portion and paste it ahead to this pattern, and before this pattern, then I will get the same signal as drawn in this plot. If I just copy paste the same pattern before this pattern and before this pattern and ahead this pattern, so I will get the same signal. What I am trying to do? Just copy this pattern, which is equal to one time period, and pasting it ahead of that pattern, continuously pasting, and before this pattern. Then I will get the same signal, and which is the mathematical expression is claiming 2. So by this mathematical expression, we can say that a periodic signal must start at time t is equal to minus infinity. As you can see that expression, in this expression we have written for all values of time. So a periodic signal must start at time t is equal to minus infinity. If the signal is not starting from t is equal to minus infinity, if it is starting at some any other point, then this signal is not a periodic signal. So for periodic signal, it must start from t is equal to minus infinity. Why we are saying this or claiming this? Because suppose we have a signal, suppose this signal, we have a signal which is starting from this point. We don't have any pattern like this. The signal is starting from this point and continue to repeat this pattern afterwards. So if we just try to copy and paste before this pattern, then we will get this pattern. But this is not the case with the real signal, as we have stated that our signal is starting from this point and we have 0 values before this point. But when we are trying to copy and paste ahead, then no issue with ahead. But if we are trying to paste this pattern before, then we will get another signal which is not the same signal, and mathematical expression is not satisfying. So that signal is not a periodic signal if it is not starting from t is equal to minus infinity. As you have seen that we have taken a signal which is not starting from t is equal to minus infinity, and if we just copy and paste ahead and before, and by copy and pasting we will get some different signal. So for a periodic signal, it must start from t is equal to minus infinity, and another very important aspect is it continue forever. It means t is equal to minus infinity to infinity. If a signal is periodic, then its range is t is equal to minus infinity to infinity. It must start from minus infinity and continue forever. Now the second property for any periodic signal is that a periodic signal can be generated or we can reproduce a periodic signal. How? If we just copy and paste a pattern which is equal to the time period of that signal. This concept can be clarified by looking at these two plots, in the first plot the signal is same. You can see that in both the plots we have the same signal, but in the first plot and what we have to do, what we are trying to get, we are trying to get the original signal by reproducing the same pattern which is equal to the time period. So in the first plot we are taking the pattern equals to the time period, and we know that this signal has a time period of 6 seconds. So in first plot we have started from t is equal to -1, and we will move till t is equal to 5 to get the 1 period of that signal. So this 1 period is enough to reproduce the entire signal. We just have to paste this pattern ahead and before to get the original signal. But it's our choice what pattern we will choose. But we have a restriction. What restriction? We have a restriction that we can choose a pattern which is equal to the time period of that signal. If we choose correctly, then we will be able to the reproduction of the signal. If we choose the wrong time period, then we will never be able to reproduce the original signal. So in the two plots which is shown in this slide, the two different regions are shaded. In the first plot we know that the signal has a time period of 6 seconds, so we select the pattern starting from t is equal to -1, and we will continue till t is equal to 5 seconds. We will select that time of that signal and just pick that pattern and copy and paste to get the original signal. As far as we are satisfying the condition, we are taking the one time period, we will get the original signal. If you look at the second signal, again the criteria is met that the pattern is adopted and the time duration of that pattern is equal to the time period of the signal. So by selecting this shaded region also, we will be able to reproduce the signal. You can see that these two shaded regions are different, and the pattern formed from these two shaded regions are different in both the plots. But as far as we are satisfying the criteria that we are obtaining the pattern equal to the time period and then copy and pasting that pattern, so we are getting the same original signal. So the statement is verified by yourself too, that the construction of any signal is possible with any segment of that signal starting from any instant. But what's the condition? As long as this segment duration is 1 period. Another very important property of any periodic signal having the time period t0 is that area under the signal over any interval of duration equal to the time period is same. That is, mathematically we can say that if we calculate the area under the curve for a one-time interval, we are not bound to select the starting point as far as we are satisfying the criteria. That is, if we are taking one time period, then we are not bound to take, or we are not bound to select the starting point. We are free to select any point as an starting point, and we will continue till time period of that signal, that is one period of that waveform, and we will calculate area under the curve, and this area under the curve will be same if we take any other point. For example, look at these two plots. If we have started to calculate area under the curve, and this is point A, and we will take one complete period, and we are going to calculate area under the curve from this point, then we will use this expression. And for example, if we are taking some another point B, for this plot it is 0, B is equal to 0, and we are taking one period and we are calculating area under the curve with this expression, then these two area under the curve are same because we are taking the one complete time period. So area under the curve will be the same. So in general we can say that we can use this expression for calculating the area under the curve or area under the interval of x of t. So summarizing our discussion for periodic signal, a periodic signal is one which satisfies the mathematical expression as shown in this slide. X of t is equal to x of t plus t naught for all values of time. The properties we have discussed for periodic signal are, the first property is a periodic signal must start at t is equal to minus infinity and it continue forever. The second property we have discussed is that a periodic signal can be generated by periodic extension of any segment, but the length of that segment must be equal to the time period. And the third property we have discussed for periodic signal is to calculate area under the curve for any interval, and we are free to select any starting point as far as the length of the pattern or the duration of the pattern is equal to the time period. We will get the same area under the curve irrespective of the starting point. A very interesting fact about periodic signal is that a true everlasting signal cannot be generated in practice for very obvious reason. You can imagine that we cannot generate any signal that starts from minus infinity and continue forever. So why we are studying such type of mathematical equation or expression or signal which is periodic if we cannot generate this type of signal practically? So we are studying because this signal, a periodic signal, serve for a very useful purpose in the study of entire signals and systems and digital signal processing. Now moving towards another classification of signal, that is causal signal and non-causal signal. So starting with the causal signals. A causal signal is one that does not start before time t is equal to 0. This is the mathematical expression that if x of t, if our signal is x of t and x of t is equal to 0 for time t less than 0, then it must be a causal signal. So let's verify this expression with the help of plots. We have three plots as shown, as highlighted by the pointer. In the first plot, you can see signal is starting at t is equal to 0. We have the time axis along the x-axis. We have time variable along x-axis and amplitude along the y-axis. So a signal is starting at time t is equal to 0. At time t is equal to 0, we have a magnitude of 2 units, and afterwards signal is having some values. But if we look at before time t is equal to 0, signal have 0 magnitude. So there are 0 value or 0 magnitude before time t is equal to 0. So this type of signal is a causal signal, because by definition, as we studied, that x of t is equal to 0 for t less than 0, and we can see that for t less than 0 our signal is 0. So this signal is a causal signal. Now moving towards the second plot. In the second plot, we can also claim that it is a causal signal, because this signal is also starting at point t is equal to 0. Before time t is equal to 0, the signal has 0 magnitude, and it is starting from time t is equal to 0. So the second signal is also a causal signal. Now look at the third signal, which is a ramp signal. As you can see, it is a ramp signal, and this signal is also starting from time t is equal to 0. Before time t is equal to 0, signal has no value. So this is a causal signal. Now come to the non-causal signals. Non-causal signals are those signals that started before time t is equal to 0. As you can see from the remaining plots, this one, this one, this one, and this one, all these four plots are for non-causal signal. How? Because we stated that for a non-causal signal, a signal must start before time t is equal to 0. And we can see in the first plot, in this plot, time t is equal to 0 is here, and this signal has some values before this time. So this signal is a non-causal signal. If we talk about this signal, then time t is equal to 0 is here, and this signal is a non-causal signal because it has some values before time t is equal to 0. The same is valid for this signal. This signal is also showing some value before time t is equal to 0, and the last signal is also a non-causal signal because it also have some values before time t is equal to 0. So the difference between causal signal and non-causal signal is very obvious. Causal signal are those which are starting from t is equal to 0, and non-causal signal are those which are starting before time t is equal to 0. Another very important point regarding non-causal signal is that an everlasting signal is always non-causal. This is very important point, please note it, that everlasting signal is always non-causal. But a non-causal signal is not necessarily everlasting. To prove this statement that everlasting signal is always non-causal, but a non-causal signal is not necessarily everlasting, please see these four plots. In this plot, the signal is not everlasting. It is starting from this point, but this is a non-causal signal, and we are claiming that everlasting signal is always non-causal and non-causal signal is not necessarily everlasting. So this is a non-causal signal, but this is not a everlasting signal. Now look at this figure. This signal is an everlasting signal because it is starting from t is equal to minus infinity and continue forever. So this signal is an everlasting signal. So everlasting signal is always a non-causal signal, and this signal is also a non-causal signal. So the statement is valid that an everlasting signal is always non-causal, but a non-causal signal cannot be is not necessarily everlasting. This statement can also be validated from these two plots. This signal is not everlasting, but it is a non-causal signal. And in this plot, this is an everlasting signal and it is a non-causal signal. So far we have discussed causal signal and non-causal signals. Come to the third classification, which is anti-causal signals. So anti-causal signals are those signals that are zero for all values of time which is greater than 0 and equal to 0. So a signal that is 0 for all time t greater than or equal to 0 is an anti-causal signal. So by using this expression or mathematical definition, your task is to plot an anti-causal signal. You can easily plot anti-causal signal with the help of these causal signal. Just focus on the definition, that is anti-causal signal is one which is 0 for t greater than 0 and equal to 0. So your task is to plot anti-causal signal with the help of these causal signals. Moving towards another classification of signal, which is energy signal and power signal. So a energy signal is one with finite energy, and a signal with finite and non-zero power is a power signal. So how we can claim that a signal is energy signal or power signal? We just have to calculate its energy and power. If the signal has finite energy, then it is an energy signal, and if the signal has non-zero and finite power, then it must be a power signal. Because we all know that power is the time average of energy. So a signal can be energy signal or can be a power signal, but cannot be both an energy and power signal. If it is one, it cannot be the other. Or we can also say that there are signals that are neither energy nor power signal, and the example of such type of signal is a ramp signal. In the plot shown in this slide, if we calculate the energy and power of these two signals, then we come to the conclusion that first signal is the energy signal and the second signal is power signal. Usually an everlasting signal is a power signal, but again we have to calculate with the help of mathematical formula and mathematical expression. We have to calculate the energy and power of signal. Then we conclude that this signal is either an energy signal or a power signal. Another classification of signal is deterministic signal and probabilistic signal. So a signal whose physical description is known completely is a deterministic signal, and that physical description can be in the mathematical form or in the graphical form. But if we know the physical description completely, then it is a deterministic signal. Other words, we can say that if we can predict the value of the signal at any time instant by using the mathematical expression, then it is a deterministic signal. But a signal whose values cannot be predicted precisely but are known only in terms of probabilistic description, and that probabilistic description is like mean value or its mean squared value, is a random signal. So a signal whose values cannot be predicted precisely is a probabilistic signal. So students, in this lecture, so far we have discussed the classification of signals. We have discussed the classification on the basis of various parameters, and the categorization we have studied are the analog signal and digital signal, continuous time signal and discrete time signal, periodic signal and aperiodic signal, deterministic signal and random signal, causal signal, anti-causal signal, and non-causal signal. Now what you have to do, you have to go through entire lecture thoroughly, and if you have any confusion or query related to any topic, you may discuss it with me in the live session, which is scheduled as per your timetable. And you may also search, if you have any confusion, you may search it over the internet, you may browse, and you may also refer to the textbook and reference book. And if the query remains unsolved, you may discuss it with me in the live session, so that all concepts must be crystal clear to all people. So in the next lecture, we will discuss more about discrete time signals, as we are more interested in discrete time signals and discrete time signals, as we are studying digital signal processing. So we have to deal with the discrete time signals and discrete time systems. In this lecture, we have discussed more about continuous time signals and general classification of signal, but in the later lecture we will discuss more about discrete time signals. What are the discrete time signals, how mathematically we can express those signals, how one signal can which is continuous in time can be converted into a discrete time signal, and how we can calculate the size of a signal, and how we can calculate the energy or power of a discrete time signal. So all these things will be covered in the next lecture.